Okay, I think we're ready to start. Hello, everyone. Just so you know, I've got a few requests to live stream this on the internet, so we're actually doing that right now. Hopefully it works. I'm not sure. Who knows? Maybe there's someone in Japan watching this with us right now, in the middle of the night in Japan. Anyway, welcome. Today we're going to do a short workshop introducing SuperCollider, as you probably know. This is the rough program for the day. We're going to start with a bit of an overview about what SuperCollider is. We're going to cover the design and architecture of it. Then we're going to look a bit at the programming language and probably write a bit of code. And then at the end, I will give you some links for some really good resources to continue this fantastic journey in SuperCollider. Yeah, so that's the program for the day. Who am I? My name is Mads Kjeldgaard, or as the Norwegians say, Mads Kjeldgaard. I'm a composer and developer, and I work here at Notam. And to those of you, there's a lot of new faces here today that I haven't seen here before. So if you don't know, Notam is the Norwegian Center for Technology and Art. Makes sense, Notam. It is the Norwegian Center for Technology and Art. And here's a bit of contact information. The top link right here to my website is very important, because if you go to my website right now, you will see something very fantastic. Unless I've been hacked by some trolls somewhere. Oh, maybe I have been hacked. No. If you scroll down to the bottom of our website, you can find a link here called Introduction to SuperCollider, Notam 2019. And this contains a link to the slides for today, so you can download them and use them at home afterwards or during the talk today. So these slides are going to work kind of like a cheat sheet later on in 2 months when you're sitting at home and you're like, wow, what did he say? I can't remember. And then I've made these handy slides for you. I have an email address. You can send me an email. I share a lot of my code on a website called GitHub. And we're on most of the cool modern social media as well, so you can go check that out if that's your thing. Here at Notam we have meetups every month for SuperCollider users. And it's in conjunction with those meetups that I'm doing this workshop today. The meetups are kind of like a loose, it's a loose and very cozy meeting every month for people who use SuperCollider or want to use SuperCollider. That's basically it. But sometimes we have people who show up and who have never used SuperCollider, and they would like a proper introduction. And the meetups aren't always the forum for that, because it's a bit more loose and chaotic, which is very nice. So I decided that let's do a proper introduction to SuperCollider. But every month we have a meetup here. The next one is in 1 week. Unless you're watching this from the future, then it's probably already passed. But next week we have a meetup here at 7 p.m. I recommend coming. And this bit right here, even though it's in a parenthesis, it's very important. There's often cake involved in these meetups. And I think there's a very friendly atmosphere, and it doesn't matter if you've never written a line of code before in your life, or you've written a million lines of code. It's really for everyone. And if you're somewhere else, if you've come here from afar, or if you're watching this from some other place on the planet, then I would recommend starting a meetup group. It's the best way to learn this kind of stuff, and it's the most fun way to do it. Once you try it, it's a very cool experience, and you really get to learn so much in such a short amount of time, and it's super inspiring. All you need for a meetup is more than one person interested in SuperCollider. And then if you have some cake, that's great. You can. There's a link here in the slide for a meetup.com page, which is a good place to follow the meetups. And you can follow them on Notam's social media as well. So let's get into it. What is SuperCollider? SuperCollider is a platform for audio synthesis and algorithmic composition. It's free and open source, and it works for both Windows, Mac, and Linux. It's always nice to have a bit of a qualification. Why should we use SuperCollider and not some of the other cool tools out there? This is kind of my short list of reasons why I think it's very nice to use SuperCollider. I think the first one is probably the most important one. It's open source and free. So open source means that the code is openly available. It's shared on the internet. You can, if you want, you can go in and read it. You can modify it. You can make your own SuperCollider if you want. And it's developed by a bunch of volunteers. And as a consequence, it's also free. So anyone can use it. Anyone who has a computer can use it. And I think the more I use it and the more I think about it, this is really the best reason for using this kind of stuff. Open source and free tools are amazing because anyone in the world can use them. You don't have to have this and that gadget. You don't need to pay this amount for a license. Anyone can use it. And I've seen SuperCollider run on computers that you wouldn't think could run anything. And it actually runs SuperCollider. So it's quite amazing. SuperCollider is pretty old. So that's another really good thing about it. You could probably argue that it's one of the bad things about it as well, but it's been around for more than 20 years. So people have thought about this for more than 20 years. That's pretty cool. And as a consequence, it's very efficient and robust and stable. So it's very hard to make SuperCollider crash. It's cross-platform, like I mentioned before. It works on all operating systems. And it contains a lot of really unique design concepts and features that really are, once you get into it, really mind-blowing. Ways of organizing sound and ways of composing and ways of thinking about art, actually, that really are encapsulated in SuperCollider, that I think is in itself very, very inspiring. And then this one of the last ones here is a bit weird. It's text-based, so why is that a cool thing? When I can sit with a screen and I can patch things together, or I can have a very nice GUI with a modern font that looks really cool, then why would I choose to use a tool that has text as its interface? And it is a weird argument, but it's actually, first of all, if you want to learn SuperCollider, you're learning a text-based code language, and it's much easier for you to transition to another code language. So like JavaScript is pretty close in syntax to SuperCollider. So that transition is probably painful no matter what, but it's less painful from SuperCollider than from something else that's visual-based. And then because it's text, you can very easily manipulate it and change it. It's like everyone here has written a Word document probably in their life, and it's not that far from that experience, actually. So you can search and replace and all sorts of things with text. And then because it's been used for so long and it's free and open source, it has a massive community all around the world. And this is really another super cool thing about it. So you can get a lot of help, and it's very friendly people. So that's another really big advantage. And what is it used for? SuperCollider is pretty much used for anything nowadays. It was originally thought of as a thing for aiding composers, so it has very strong support for composition, whatever that might mean to you. It's a very open idea in SuperCollider. You can get into some really low-level sound synthesis stuff. So if you want to experiment with different ways of patching sound, you have support for that. It's used for live coding. So live coding is starting to become a popular way of performing live. It's something I do myself. It's one of the reasons I got into SuperCollider originally. So I use it to play concerts where I improvise the code, and I show it on a screen like this in front of the audience. And sometimes, even though I said before that it's hard to make SuperCollider crash, I sometimes make it crash in front of an audience. So that's I think that's really interesting. And improvisation, you see it in Oslo. You see it mixed, used in mixed performances with instrumentalists. Networked performance is another use for it. Networked performances, you don't see that often, but it's basically networking together computers and then playing together in however you want. And then for installation use, of course. And actually, you see it used quite a bit here in dance and theater. I think that's very interesting. I hadn't experienced that before coming to Norway myself, so that's really cool. And then immersive sound. It's one of those kind of empty sound words we have in our vocabulary. But immersive sound meaning multi-channel stuff. So that's another use for it. Here's a few examples that you should probably just check out when you get back home. A few links to some interesting uses of SuperCollider. The first is Rosen and Flak. It's a dance company. They use it to combine choreography with SuperCollider. It's very cool. They have these trackers on dancers, and they become kind of part of an instrument. It's very nice. This is a link to a video example. And then you have a theater, post-theater group, I should say, in Oslo called Verdensteatret. Has a very proud tradition of experimenting with technology. They use it at their core as well. And then Rennick Bell is a very good example of what I said before about live coding. He's doing some very interesting stuff with live coding. And he's developed his own interface for SuperCollider, but that's a different talk. He has SuperCollider behind it all. And then Streifenjunko is kind of an improvised music group here in Oslo as well that's using SuperCollider in very interesting ways, I think. So I think today what I really wanted to kind of get across is how SuperCollider works and how it's designed and what the architecture is like. Because most often with these kind of introductory workshops in SuperCollider, we focus on making sound as quickly as possible at whatever cost. And that's not always the greatest strategy, because you would end up leaving a workshop like that with a bunch of code that you, one day later, you have no idea what it was that you actually wrote in this text document, and how are you going to work with it, and how can you continue. And so instead today I'm going to choose a slightly more boring route, because I want to explore the fundamentals of it so that you can get a really strong foundation for continuing to learn SuperCollider. So we're actually not going to make any sound today. We're just going to have a look at SuperCollider itself. And so the first part of that is the design of SuperCollider. A very, very short history of SuperCollider. Like I said before, it's been around for more than 20 years. The first version actually came out in 1996. It was based on a Mac object called Pyrite. Cost $250 plus shipping. That would be $50 to Norway. And it could only run on a Power Mac. It was designed by a guy called James McCartney, originally as closed source proprietary software, so you couldn't see the source back then. It was like a lot of other applications, a thing you had to buy. And you would get a box in the mail containing SuperCollider. In 2002, though, James McCartney decided to open source the software. So all of a sudden anyone could see the peek into the code, they could change it, and then a community started developing around developing SuperCollider. So I think that's it's a very interesting example of kind of commercial software opening itself up and then just completely blossoming. When we say SuperCollider, and when you download SuperCollider, you get an application that's actually a bundle of applications. And this can sometimes be a bit confusing. That's also the reason why SuperCollider is often referred to as a programming environment, because it contains a lot of different things, not just a programming language. The three main components, arguably, are the text editor, which is what you see when you download it. You see the text, and we're going to get into that in a minute. Then the programming language itself, that's another program. If you have a terminal in your computer, you can write, once you've installed it properly, you can write sclang and you would get kind of like an interface for it. And as well the sound server, which is called SC-Synth. And I should mention, I'm going to mention this a couple of times more in this talk, that sometimes we're going to refer to the language as the client. This can be a bit confusing, but bear with me. This is how, at its core, SuperCollider is normally configured and how it is designed. In SuperCollider, you have two things. The client, which is the language, and then the server, which is what makes sound. And this can be very confusing because, at least for me, when I started working with SuperCollider and people talked about servers, I was imagining this tower of computers in California. And you could use the tower of computers in California to make music with, but more often than not, in SuperCollider, what we mean by the server is a program on your computer. So the server is what makes sound in SuperCollider. You can compare it to this, it's kind of the same thing as in Pure Data and in Max, where you have this button where you say DSP and then you turn it on. This is kind of the same engine, idea of a separate engine that you have in SuperCollider. So we call that the server. Yeah, so that's confusing, but bear with me. The client is the language, and the server is what makes sound. And then those two are connected through something called Open Sound Control. And this is something that, this is how SuperCollider has been for a large proportion of those 20 plus years. And this is one of the reasons why it's so brilliant. Because when you separate these two things and connect them through this arbitrary connection, you can do some pretty interesting stuff. For example, you can have multiple sound servers. So we could, right now, if I wanted to, I could make all of you pull out your computers and start SuperCollider, and I could control all of them from this one computer. So that would be one client controlling a bunch of sound servers. And another consequence of this is that because it's using Open Sound Control, which is actually, it's a big subject, but it's kind of a way of sending, normally it's a way of sending data over a network protocol. This isn't normally something you would think about when you use SuperCollider, but that's a super interesting idea, because actually this sound server, it could be in California. I could control a sound server from here, which is in California. So there's a lot of interesting ideas there. And another consequence of this design, where you have a client that's separate from the thing that makes sound, is that you can actually change the client or the language to something else. So if you want, you can use Python or JavaScript or something else, if you don't like the programming language. Or you can design your own whatever language. The same for the text editor, which we refer to as the IDE. You can exchange that for something else. I use, personally I use this thing called Vim, which probably isn't recommended for beginners. It's a bit hardcore, but I like it. And there's like a bunch of different text editors that you can use instead of the built-in one with SuperCollider. And so the reason why you should use something else maybe is that if you're already working with code, if you're a web developer and you prefer this one thing, Atom for example, then it would be sometimes, at least that I find it that way, then it's kind of annoying to have to get used to two different text editors and the shortcuts and stuff like this. So sometimes it can be nice to just do all of your coding in one editor. So that's why I use this thing called Vim. And then the sound engine, you can actually use SuperCollider without using the sound server at all. So you can use MaxMSP or Ableton Live or Reaper. You can basically control any program that allows input via Open Sound Control. And fortunately, a lot of modern software allows such a thing. I'm not sure if Pro Tools will allow you to let it be controlled by SuperCollider, but a lot of other things will. So this is kind of already an interesting idea of what you can do with these modular components that SuperCollider is. When you download SuperCollider, it comes with a lot of functions and stuff built in, and you can keep adding to that yourself by writing class extensions or use the built-in package system. So if you've used another programming language like Python, then you're probably used to this idea of downloading packages that allow you to, I don't know, interact with an Arduino or something else. And it's the same in SuperCollider. They have chosen to call them quarks. So a package in SuperCollider is called quark. It took me a while to remember it's called quark. A quark is a package in SuperCollider, and that's it. And a separate thing is the plugins. So you can download, and you should, once you install SuperCollider, you should download these things called SC3 plugins. And they're not quarks. They're a different thing altogether. So the plugins are basically extra sound functions that were developed by the community. And so some of the functions in there are vital to having fun in SuperCollider, and some of them are very poorly developed because they're made by the community. So it's a mixed bag of stuff, but a lot of really interesting and cool sound making machines that you should definitely install. Yeah. Okay. Let's have a look at the text editor called the IDE. This is what you see when you download it. It has a lot of. It's perhaps not the most aesthetically pleasing program in the world, but it has a lot of really cool features. And I'm going to show you some of them now. I have a program running here that says that we're about to start, but we have actually started. Let's get rid of that. This is what it looks like when you install SuperCollider. And generally we can divide this into 3 components. We have a document here over on the left, where I'm writing this now. Over on the right, on the top here, you have a help browser. Here you can search for help. So, help. There's a bunch of stuff here. And this is one of the things you should spend time on when you learn SuperCollider. You should get comfortable with the help system because it will allow you to become independent quite quickly. And then down here on the bottom right is the post window. The post window is where you see the output of your programs. We're going to spend some time on that in a bit. Down here in the corner is something that it's almost impossible to see for you guys, but it's down here on the right. You have this bar, which will give you some different indications of how much your system is struggling with whatever you're doing. And if you click it, you get a bunch of things here that are really vital. So if you want to make sound, press boot server. We're not going to use that today, but I just wanted to show you that there's a button there. And now you can say quit server. Let's kill this. But when you see the server booting, this down here will turn green, indicating that it's on and using CPU. So right now it's using 2.4% of the CPU. I'm not sure what the second indication here is. Maybe it's some kind of average, I'm not sure. U is the amount of sound objects that you're using. S is the amount of synths, and so on. You have a very well hidden over here, you have a volume, master volume for the whole program, and a mute button as well. And this menu contains a lot of good stuff. For example, recording and ways to kill all sound servers and reboot and blah blah blah. So that's super helpful. there's a bunch of keyboard shortcuts that you should get familiar with when you use the IDE. This will help you speed up the development process for you, and sometimes save your hearing. This is arguably the most important keyboard shortcut of all of them. If you press Command on a Mac and then punctuation, dot, that is, or Control on PC, and then dot, it will stop the sound. And I cannot stress how important this is, because very, very often when you work with SuperCollider, you get very excited, and then you make a lot of noise, and you can very easily make a lot of noise, too much noise even. I personally take the bus for very long rides between here and Denmark sometimes, and I like to sit there and with my headphones on and nice and calmly write my SuperCollider code, work on some nice new composition idea that I had, and then accidentally make a bazillion delays on something with a lot of feedback, and then like, and then I look like an idiot. But then I very quickly use this kill-all key. So memorize this. You're gonna need it. Everyone needs this keyboard shortcut. And there's some other things here that are really important. Control Enter will evaluate code, or Command Enter. And then Control D will open the help browser for whatever is under the cursor. And I can just show you how that works. So I can, for example, write Synosk and then press Control D. And then over here on the right you will see a description of it and the whole help file. So that's Control D or Command D. Super important. A very cool feature as well with the help system is that you can actually evaluate the examples that are in there. So if you press Command Enter or Control Enter, you will evaluate the code, and then, as I said before, you kill it with Command or Control dot. So let's try this one. Very nice sine wave. Another cool thing that you probably noticed before is that as soon as I start typing something and I've written it in the correct way, some nice stuff happens. So let's write this again. Sin. Okay, I have this list of nice things. So it's an autocomplete. Sin grain. Sin ask. Okay. You can see here you actually get the whole, or some of the help file here. So that's helpful so often. But this this autocomplete is super nice. So sin R, and then I press enter to complete. So you're going to need that often as well. So the IDE is because of the way SuperCollider has been designed, we can kind of live. It's a very we can live code. it's an almost an empty expression now. Live coding. We can actually live code, and one of the simplest ways we can do that is by using it as a calculator. So if I write 1 + 5 here and evaluate it, I get the result over in the post window. And so the programs that I'm writing can be running, and while I run them, I can do blah blah blah, and then see what the result is. This is very helpful sometimes when you just want to see what happens if I divide 6 by. Maybe you're a math genius, unlike me, but I'm not very good at math, so sometimes I have to think before I pass this into something dangerous, and I'm like, what is 6 divided by 7? Okay, 0.85. Okay, I can probably use that. So that's a way you can use the IDE. Yeah, we've covered the auto-completion, the status line. Yeah, that was the text editor. It has also, I just want to show you, it has this thing up here, which has a lot of nice features as well. Sessions is a way to, let's say you have 3 different documents that is part of composition A, and then when you want to work on another composition, let's call it B, then you can save those as different sessions containing those particular documents so that you don't have to manually open them and remember, was this document part of that project or whatever. So it's kind of a project manager. It's pretty nice. Normal text edit things here. Preferences. You can change the colors and a lot of nice things here. Language. You can see the quarks here. This is the very ugly interface for the package system. And the sound server has a lot of settings and the help files. Another thing I just wanted to mention quickly, no wait, I'm going to get back to that in a minute. So I advertised this as a gentle introduction to SuperCollider. And this afternoon when I was finishing these slides, I realized that, oh my god, this isn't gentle at all. This is quite brutal. This is pretty hardcore stuff. But I want to introduce you to some things that are vital to understanding SuperCollider, the programming language. And some of it is a bit difficult, but I just want to gloss over it now, and then maybe it's going to be a bit confusing, but then maybe in a month or a week, when you're taking a shower or walking your dog, you're like, there it is. Now I understand what he meant when he said this thing that day. And this is about how the SuperCollider programming language is designed. So in SuperCollider, everything is an object. That doesn't make any sense, but hopefully it will in a moment. And all objects are instances of a class. Still doesn't make any sense. What does he mean when he says everything is an object in SuperCollider and that all those objects are instances of classes? I can use this pen as an example. This pen, you could say that this is a pen object. It's an instance of the class pens, but it's a specific pen. It's a Muji pen made in Japan, and it's black, I think, or blue, dark blue, navy blue. It's a navy blue pen from Muji, but it's of the class pens in general. So this is almost philosophical. It's the idea of a pen is encapsulated in a class, but then the actual pen itself is the product of it. This is the object. And the same goes in SuperCollider. So the idea of a pen describes what we can use a pen for. The idea of a pen is different than for example, the idea of a cheese. I can't use a piece of cheese for the same things that I would use a pen for. It wouldn't work. Believe me, I've tried. A pen can be used to write things. I can use it to put an X on my hand to remember things. If I tried that with a piece of cheese, then maybe the smell would help me remember, but I wouldn't have a proper mark here. So that's actually the gist of it. It's still abstract and weird, but that's the idea. So the class is the idea of something, and then the object is the specific sort of one object born from that idea. It's very hardcore. So what can an object do? An object is always able to do something. Like I said before, I can write with this. The something that it can do is called a method. So a method for this could be eject ink. That's something it can do. For a cheese, it could be start smelling. Could be a method. So this is the gist of it actually. And then kind of a disclaimer down here. The methods are parentheses often documented and sometimes explained in the help files. This is the product of SuperCollider being driven and developed by volunteers. Sometimes they get lazy, sometimes they don't have time, and then you're left on your own. But quite often it's documented what a pen can do, for example. And I want to show you how this works when you're looking for help in the help system, because that's why I'm showing you this now as one of the first things. Because the idea of objects and classes is actually kind of like an advanced thing you do after working with SuperCollider or any programming language for a while. You have to kind of get familiar with it a bit, but for SuperCollider I think it's very important to get this early on, because it's going to help you find help, which is, I think most people like to get help sometimes. And so the way it works is, let's hide this one. When you open a help file, you see this very clearly. All classes or ideas of something inherit some of their functionality from kind of a parent. This is still weird, but let me give you an example. Integer. So an integer is a whole number. It's 1, 2, 3, 4, 5, blah blah blah. It's not 2.5 or 3.5. But an integer is one of many kinds of numbers, and we see this actually in the help file. This little, I only realized this recently actually, this little colon here means that this is getting some of its functionality from this guy, this guy. And he's getting some of his functionality from this guy. And then he's getting some of his functionality from this guy. And then at some point we end up with object, which is the general idea of objects. So I think you can find the meaning of life in this one, actually. But an integer is just a number. It's a type of number, so it's a type of simple number and blah, blah, blah. And the reason I'm mentioning this is that often you will look up a help file for something, and then maybe this one is a quite good one actually, but sometimes to fully understand what an integer could do, I need to look at what a number can do. Sometimes it's better described here. So a number is pretty simple. You can see you can use it for addition or subtraction and multiplication and blah blah blah. And this is what I said before. This is the thing. These are the things that an object can do. Called them methods before, but for math it's plus, minus, division, stuff like that. I'm gonna have a bit of water. That's actually, yeah.
The ordered tree was represented on the last page. If you go back.
Here?
No.
Or in the slides?
No, you had the integer, the number.
Aha, yeah.
Does that say something of the hierarchy?
Yeah.
It does.
Yeah.
Perfect.
So you can see the hierarchy. You can actually see the hierarchy, but I keep forgetting where you can see it. But there is one place you can see it. It's not super pedagogical, but there is a thing called, I think, class tree. Yeah. Yeah. Good luck understanding this. But here you can actually, if you have the time, if you have a lot of time in your life, you can actually follow the lines here and go, okay, object, okay, come on, number, come on, all right, let's go, number. Yeah, it's in there somewhere. But you can see how it's laid out here. This is, I wouldn't recommend doing it this way, ever.
A lot of classes are undocumented though.
Yeah. Yeah, it's also because sometimes you don't directly need a class. They just exist for other classes to inherit from them.
Yeah.
And so they don't actually need to be used directly. So then sometimes to save a bit of time and spend more time with the family, then people don't document them. Or maybe they just want to get to McDonald's very quickly, I don't know. Let's see, I'm not sure if this one actually contains a better... No, this is just the alphabet. That's not any better. Okay, so that was actually the hard part, and if you didn't understand it, then try kind of chanting this line again for yourself when you take a shower the next time. Let's see where it is. Everything in SuperCollider is an object. Everything in SuperCollider is an object. Just keep saying that, and then at some point it becomes the truth. Yeah, as I said, that was the difficult part. Let's actually write some code now and see what we can do. The first task of any programming course is to write hello world. It's the classic, and this is how we do it in SuperCollider. Let's try it. Hello world dot post line, and we can't see it because I hit my post window. There it is. Okay. Hello world. If you can do this, you've passed the first test of any programming course. This is the most important one. How do you make it say hello world? This is how you do it in SuperCollider. Oh boy. Yeah, let's save that one for later. Yeah. Okay. Yeah, just a quick note about what I said before about using SuperCollider as a calculator. You can use it as a calculator, and you definitely should. But there's one thing that you should be very aware of with SuperCollider if you have ever done anything with math in your life. Then it's probably a bit counterintuitive how it handles hierarchy. So I can show you an example here. Normally, when you work with math, if you've had math in school, then if you say 2 plus 2 times 10, then you would probably expect it to first figure out what is 2 times 10, because that's top of the hierarchy here in the math, and then after that add 2. But in SuperCollider, it's a different thing altogether. It becomes 40. Should have been 22. So why does it become 40? That's pretty strange, but that's a thing about SuperCollider that you just have to remember. If you want this, if you want precedence, you have to add manually a parenthesis. And then it becomes 22. I just want to mention it early on because it can be very, very confusing because it doesn't immediately make sense. And as we can see, we can use brackets to create mathematical hierarchy. The syntax is important. So the syntax is kind of the grammar of SuperCollider. If you get it wrong, you get an error. And those errors sometimes are very, very overwhelming because the error system, I'm not sure why, but it's not so smart. But usually at the bottom, if you screw up, it will say somewhere syntax error. And then the error isn't something esoteric, voodoo, your computer hasn't been haunted. It's just you have made a typo. So for example, if I wanted to make a random number, I could go 10.rand, and then it will make a random number between 0 and 9. But if I, for example, had forgotten to put this dot in there, it would say error, syntax, blah blah blah, and it's in red even. And then it says unexpected name, this doesn't make any sense. The important part is here, syntax error. And then it actually points to where the problem is. So the error messages in SuperCollider can be overwhelming, but keep an eye out for these syntax ones. They're the easy ones. We use brackets to create blocks of code. This is going to make more sense in a minute. So to make a block of code, we put parentheses on different lines here. So for example, we saw before that I used post line to say hello world. Do that here, hello world, that post line. And then at the end of each sentence, we put a semicolon. And this is super important, because then we can add another sentence inside of this block. It could say hello Norway, dot post line. If I can actually spell it. Alright, so now if I press Control Enter, you see that it posts both of them at the same time. And this is a way to structure code and kind of divide the functionality in your program as it grows, and sometimes it's just a way to do things more easily instead of manually doing every line. You know, let's say you're at a concert and you want to say hello world and hello Norway immediately, and of course it's better to have them like this. Mm-hmm.
Can you get back to code?
Mm-hmm.
Yeah. Why do I always get like the one with the error as well? And the one of the errors we saw earlier, like this line parse fail. That's the error I always get, but it doesn't really help me understanding what I did.
So the question is, why do you get this arrow at the end, right?
Yeah, and also why do I always get like this sort of error that doesn't explain me where the error is?
Yeah.
Yeah.
Okay, so I'm going to start with this arrow first because that's the easy one. The arrow is, it points to the result of what you just did. So it's everything, I said before that everything is an object, but also everything returns something when you evaluate it. And sometimes that something can just be nil, so that's nothing. But it always returns something. And in the post window, you can tell by looking at these arrows, they point towards whatever is being returned from the last line of code in the thing that you evaluated. So actually, without saying post line, if I just wrote 9,000 at the end here, and then did this again, the arrow would point to 9,000, because that's at the end of what we evaluated.
Alright.
So that's what it spits out, and then the arrow kind of says, this is what you get. This is what you get from evaluating this. And the other question, what was that?
Yeah, you show us an example of an error.
Yeah. Okay.
Earlier on.
Let's make another error here. Hello. Hello. Post line.
Yeah. You have both syntax error that explains you what is there, and then you have like this other error with like nil.
Oh yeah, command line passed.
Yeah, and
That's
sort of an error I always get no matter what, and I'm like always wondering what does that mean and why it's not showing me where the error is. Sometimes I don't get the first one.
I don't know actually, to be honest.
Yeah,
I think this is just SuperCollider's way of saying you have a
it's
syntax error.
notification that you have an error or something like that.
I think it's basically just a way of saying you have a syntax error. That's the first problem, and then as a result of that, nothing works.
Alright.
command line pass failed.
So there's generally no way to find where the specific error
Yeah,
is?
there is. But it's a bit hardcore. I think there is actually a help file that could explain this better than I could. Understanding. Yeah, isn't that what it's called? Yeah. Understanding errors. Yeah. So this help file will teach you how errors are supposed to be read. Errors in SuperCollider are super confusing sometimes.
Has a debugger or something? Maybe you can have some checkpoints or like breakpoints.
Yeah, usually I use stuff like postline to tell me what's going on at a certain point in the code. So if I have a piece of code that's this long and then I think something is going wrong in the middle, then I put these postline things in the middle to figure out what's going on there. We don't have proper debugging like in some of the smarter text editors that are out there. But we have, if you're interested, and you should probably read this at some point, this help file. This is a very typical error that you get. And, you just started programming, you just started making sound with code, and then this is the error you get. And what do? You call it a weekend and then start playing guitar again. Because this is, does not understand error, report error.
There's another page, if you go to the top of this one, there's a link to the debugging tips.
Yeah.
Which is good.
Oh yeah, that's really good as well, yeah.
Oh.
Yeah, debugging.
Ways to get information from the server of what's going on or what is going on.
Understanding errors. But generally these errors, how to deal with them, I don't know. Usually I start from the bottom. It's a type of error called stack trace error, where it kind of like looks through all of these objects and the objects of the objects and blah 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 to like figure out what the hell is going on and what is the state of each of these objects when this happened. And this is actually what you see here. And it's screw it. It's very confusing in the beginning. So an expression, this is just mostly a way of talking about this code. An expression is marked at the end by a semicolon. So an expression is the code equivalent of a sentence. A sentence, unless you're a poet, a sentence usually ends with a punctuation. So in SuperCollider, punctuation is a semicolon. So this is very important because if you don't have a semicolon, you will get errors. And the reason you get errors is that when you evaluate a piece of code, it's interpreted by the SuperCollider text editor. And the SuperCollider text editor interpreter isn't very smart. It's pretty stupid actually. So it doesn't understand what's going on. When is the beginning of this piece of code and when is the end of it if we don't use these semicolons? So let's actually try this one. See how that works. So I have two expressions on the same line here. They're on the same line, right? Yeah. I evaluate them and I get the result of both of them. But then if I remove the semicolon here, get an error. But this way you can sometimes condense things. It's going to make your code a bit uglier, but that's an expression. And you've already seen this idea, but the way you make an object do something is by writing whatever the object is, dot, and then what you want it to do. So, for example, this is actually this line right here is a string object. A string is a bit of text with these quotation marks around it. And it can do a bunch of things. And we've already seen one of the ways you can make it do something is by writing postline. Or another way you can do something with it is by writing scramble. And then just becomes gibberish. And all objects in SuperCollider can act according to methods using this dot notation. So you can actually chain these together. So you say scramble postline. There's two ways of writing this. You could. This is actually one of the annoying things about SuperCollider and other open source software. Is there's always 30 different ways of doing the same thing, and it's super frustrating. And it's the product of many years of democracy, I guess. And you know, we like democracy and everything. It's cool, but it's also a bit messy sometimes. But I just want to show you that sometimes you see it written as this, so you can turn it around. So what was at the end, we could put at the front. So this is the same as writing it like this. This is the exact same.
When you chain up the dots, basically, you write post line and then scramble. Is there a hierarchy in there? Will it first post and then scramble?
So the question is, what is the hierarchy here? If I write it like this, then it's just going to start from left and then
Scramble
do the
and
next
post.
thing. And then when it's done doing that, it's going to return it with the the arrow before, saying that this is what happened, and then it's going to go right. So you can kind of think of the arrow as saying, send it that way, and then that's actually what happens here. So it's we've got this thing, and the result of that is sent to this scramble thing, and the result of that is sent to this thing, post line, and so on and so on. You can keep chaining this until your computer explodes.
Yeah.
But yeah, that's a very good question. The hierarchy is from left to right.
Yeah.
There's a lot of similarities between code and text using natural languages, and this is one of them. Sometimes you have instances where the code kind of works behind the scene and then doesn't make sense anymore, but generally this is the case. Yeah, I've covered those. When you are writing code, one of the most important parts of it is to write comments. And comments are used to remember and document whatever it is you did the night before. Often when you write code, it's if you don't write what the reason why you did it or what it's supposed to do, then if you go back to it in, for some people like myself, for example, in one day, you read it and you're like, what was I thinking here? What's the purpose of this? What is the meaning with my life? And we use comments to help us remember this, and sometimes just to kind of deactivate things. So let's see. There's two different ways you can write a comment. So for example, to document that this is a result of Giuseppe asking a question about chaining things, we can write // and this becomes a comment, and then Giuseppe asked a question. This is the result. And if you evaluate this, then this interpreter that I said before was quite stupid. It actually is smart enough to know that if something starts with this, then ignore it. So this is only this comment is only used by us who read the code. The interpreter just skips it. It doesn't care. Whatever's in here, it doesn't matter. And sometimes that's useful if you want to deactivate something. So for example, if I got sick of this line of code, I could write this and then nothing. Doesn't work anymore. And that's super helpful. There's another way you can write code comments in multiple lines, and it's using this notation. This is cool if you want to write a poem. Those are red, violets are blue, blah blah blah. What rhymes? Yeah, whatever. Whatever rhymes with the above. This is my new poem. And this is ignored as well, so if I evaluate this,
Not
in the correct way.
Didn't like your poem.
This is ignored as well. You've seen a string. Strings can be attached together. Sometimes we want multiple strings added together. This is called concatenation. We do it like this. And the reason I'm showing this now is because in a minute we're going to use it for something slightly more fun, hopefully. So let's say this is the first part of a very cool sentence. You will never guess how it, and that's the end of it. Yeah. But we would like to have an ending here, so let's add an ending by adding these two pluses and then say ends. Now this becomes one. Actually very hard to see. It becomes one.
Moving the editor around a little bit?
Yeah. Let's see if I can do this without. Right. Is that better?
Yeah.
Yeah. Where was I? Yeah. So we can attach one string to another by using plus plus. We're going to use that in a minute for something slightly more enticing. Symbols, I just want to mention them. We're not going to use them today. It's a different kind of, looks like a string, but it isn't a string. You see it quite often if you read SuperCollider code. You see it written like this. So it has this weird. I've written backslash here, but maybe it's a forward slash. I'm not sure what it's called, but you see it very often in SuperCollider code. Sometimes it's written like this with a singular quote, and we use it to name things in SuperCollider. That's usually what it's used for. So we're not going to use it today. I just want to show it to you because it's one of those things when you read the code for the first time. What the fuck is this? Yeah, let's gloss over this. Symbols are used for naming things, basically. So we need a way to store data when we are working with code, and we can use something called variables for that. So let's say we have this example from before where we have the first part of a sentence. Let's put that in a variable called first part, and then a semicolon at the end. This, to me, makes the code a bit easier to read, because then we can write first part, plus plus, ends. So to make a variable, you need to write var for variable, and then a space, and then the name of the variable. When you do this, a piece of your computer's memory is kind of being stolen, and SuperCollider says, I'm taking a bit of your memory, and I'm going to hide something in there. And what we're hiding in there is this very bad sentence that I wrote. And the way you put something in there is using this equal sign. And this is very nice, because then we can kind of divide our code into variables, and then it becomes easier to work with. So let's actually make another variable here called second part with this part of it. So we can say first part plus second part, and have an error. Because I forgot, this is a good example actually, because I forgot to put a semicolon here. Someone guessed it already. Could he? Yeah. So now it works. All right. Say that someday I wake up and I'm like, now I'm a poet. I want to do things differently with this language. So now I want the second part to be the first thing, and then the first part. You will never guess how this is the first blah blah blah. That's how you make poetry, basically. I'm probably gonna get so much hate mail after this talk from angry poets around the world, threatening to kill me. But variables are super important. So what happens here, I think, as a consequence, is that we divide this thing into several parts, and then it becomes easier to read for the first, and then becomes easier to work with as well, and kind of more flexible. Quick note about the names of variables. You can call them a lot of things. The most important thing, though, is that you don't use a capital first letter. Fortunately, if you do that, SuperCollider is going to make an error for you, and you can't use it for anything. So, as you see, we get a syntax error. It doesn't know what to do with this. And that's because all classes in SuperCollider start with a capital letter. So it thinks, okay, first part must be a class because you used a capital letter, but it's not. And then it gets confused. So just avoid that.
Just push question.
Yeah.
If you store something in a variable in between two parentheses, can you use them later in?
That's a super good question. So the question is, if I put something in a variable in the parentheses, can I use it later? I'm going to get to that in, I think, one slide. So just quickly before I get to that, there's a few other things that you can't use for variable names because they're used for something else. Nil, var, you're already using var, arc, and false and true. So it's kind of easy to get used to because you will just get a syntax error if you do it. So let's call this actually var, var. Then we get a syntax error again. But if you call it var, then it works. But it doesn't know. Yeah. Va. See? Here's the answer to the brilliant question we had before. What we actually did here was make a local variable. And this only works. I can only use the second part. Actually, let's use the var variable because it has such an amazing name. The var variable only works inside of this parenthesis. So if I evaluate this and I say, down here I want to use the amazing contents of var, and I want to mess them up, so I scramble them because that would be amazing. And then what happens? The variable var not defined. We just define it. That doesn't make any sense. I just defined what var is. It's a variable containing this sentence. And the problem is that it is a variable that is local to this block of code. And you can actually see the extent of this block if you just put the cursor here. It's you put it at the end. You can see it becoming gray. And this is a way for the SuperCollider IDE to tell you. It's a way of saying this is the block and this is the scope of the block. So whatever happens in the block stays in the block. Mostly, unless we use global variables. So what we had before with the var word was a local variable. It only exists in the block. But we can use a global variable. the reason I use these quotation marks is because we don't actually call them global in SuperCollider. It's a bit more. It's a bigger subject, but it's they're not global. We call them environment variables. And there's two ways of writing environment variables generally. The easiest one is to use the letters of the alphabet. So A is an environment variable, and B is, and C, and blah blah blah. So actually, if in here we wanted to do have a second part be available in the rest of our program, then we put it inside of a environment variable. So let's put it inside of Z, and then change this Z. This still works. Let's see if we can mess it up. Yeah. Now it's a variable because it's inside of an environment variable. So it's the entire alphabet except for Scandinavian letters and probably Hungarian ones as well. And definitely Georgian ones. And you can use those first letters of the alphabet as environment variables, and that's sometimes use it to prototype things, or if you just have this one thing that you use constantly, you put it inside one of these. Another more common thing is to use this notation. Put a tilde in front of it. This is called a tilde. It can sometimes be hard to find it on a keyboard actually. If this isn't a character that you use. I didn't use it very often before writing SuperCollider. Oh, it's going to sleep. I didn't use it very often before writing SuperCollider, and it's oh, we're waking back up. And it's actually kind of an annoying thing to write on a Scandinavian keyboard, but at least on mine it's Alt, and then this brr thing kind of has a top hat, 2 umlaut, and then yeah, this what is it on a Mac? Does anyone know what it is on a Mac?
Alt, og så det den over 18. Så rett til venstre for M.
Alt?
Nå, nej, det kan være, du skal
That's a Norwegian Mac.
Jeg har
Mine is
Alt
Alt 5. No,
Alt 5
in
on
the Italian keyboard it's Alt 5.
Oh yeah, Italian.
In Italian it's Alt 5.
Yeah.
What is it in
In case
Norwegian?
anyone else is-
And on the Norwegian Mac keyboard, it's Alt and the button above the AST key.
Oh, okay.
Oh.
So in the Norwegian one, it's on a Mac it's Alt and the button above the at key.
That's a total knapp.
Okay. Yeah, so that's
Alt button and Alt.
as I said, it's the kind of character that you don't really use that often, at least if you're not in a Spanish-speaking part of the world. So we can turn something into a environment variable by adding this thing in front of it. And so then that's actually really cool, because sometimes if we put everything inside of variables that just had one character, then we could very easily end up with a program that is a nightmare for us, because what was Z again, and what did I put in W, and what's going on in L, and who even knows about K anymore? It's and B, I don't even remember B. So sometimes we want something that's a bit more descriptive, so we make an environment variable by adding this famous tilde, and it becomes yellow. And let's do it down here as well. This is now an environment variable. As you saw, I removed the var part. So the var just says whatever's coming here is local to this block of code. We remove it, and then it's no longer local, but we have to add this tilde to make it global. So let's see, this still works. And then let's try messing this up. Yep. And this is actually a super, pedagogically super bad example, because this is just bad code, isn't it?
And you don't need to add the word var before the variable if you put the tilde.
No, you don't need the word var if you add a tilde.
Yeah, right.
Let's call this sentence part instead. And so let's just because making errors is sometimes a big help for understanding what's going on. Let's try putting var, and then we get a syntax error again, and it's pointing to it with this little top hat and saying, "This is the problem. Something's going on here." And we remove the var, and it works again. Before we move on, I just want to point you to these. There's two help files called. I put the links in the slides, but I just want to point to them because they're quite useful. There's a lot of, as I said before, there's different styles of writing SuperCollider, and as a consequence, there's this thing that we know of in all programming languages called syntactic sugar. And syntactic. It's very hard to say. Syntactic sugar is where you kind of have these language shortcuts for writing something. And just a quick example is if I want to have all the numbers between 1 and 700, I could write them like this. And I would get a list of all the numbers between 1 and 700. This is syntactic sugar. And there's a lot of it in SuperCollider. So if you ever see a symbol or a kind of weird style of code, then I would advise you to look into these two help files I've linked here. They're probably in there somewhere. Symbolic notation is a SuperCollider way of saying weird symbols. Weird characters that are hard to type on a Scandinavian keyboard. They are in here, and the meaning of them is also in there. Okay. We're almost done. We're at slide 50 of 68, and we're doing really well. What we've done so far has been pretty limited, but now we will get to the fun part. Functions are super important, and once you start writing functions, you're basically a master of SuperCollider. This is the really important stuff. So what is a function? A function is a reusable encapsulation of functionality. So it's basically a way of saying, I want to scramble this sentence. No, that's a bad example. We could make this into a function, this whatever we wrote here, if I wanted to reuse it later. So I can encapsulate it in a variable called f, like this, and then equals, and then put these curly braces around them, like this. Now you see that whatever's inside these curly braces becomes gray, and that's because that becomes a code block in itself. So if I was to make a variable in here, then it would be local to this code block. But we'll get to that in a minute. So what happens if I evaluate this now? It returns a function down here, but we don't get this amazing poetry that we wrote before. So to access this poetry, now, because we put it inside of this guy called f, we just write f, and then what's the value of the function? Dot value. Yep. So that's a way, if you want to reuse some code you've written, which is something that you do want to do when you write code, then you use functions, and we use them all the time. So when you write code, one of the high ideals is to be lazy. Being lazy is very good. And what that means is that instead of having to manually type this thing out every time, I put it inside of a function so that I can reuse it. So this is one of the few examples in your daily life where you're allowed to be lazy, and where it's not only allowed, but it's actually the ideal of life. So remember that. Just try to always be lazy. Yeah.
Can you call it anything else
Yeah.
than a letter?
Yeah. So what we did here was actually
The same as.
exactly the same as making a variable.
Yeah.
So we could say call it tilde nice function instead, like this, and then God, yep, and then it's the same. And you could probably guess that if I put this in a var, nice function, then I completely fucked it up, didn't I? What's the problem here? Nice function. Can anyone guess what I messed up here? Var nice function. Yeah. So then it only works in here, inside of the scope of this parentheses. So I just put it inside of a local variable. But if I take it outside, let's take this outside, then it doesn't work anymore. Nice function isn't so nice anymore. It's just an empty, undefined variable. And as I said before, repetitive code. So if you find yourself writing the same kind of code many times, then it's probably time to write a function so that you can define that functionality one time and then reuse it for whatever purpose. This is very simple. As I said before, we can write .value to get the value of it, but we can actually also use some syntactic sugar. Sometimes you will see that. Let's put this inside of nice function again. Get the functions result like this, or you can say dot parentheses. It's the same thing. A function can take arguments, and this is where it becomes smart, because what we've done now is we just put some code inside of a function and we can keep calling it again and again, but it's kind of useless because we can't change it. It's the same thing. So instead, let's add something called an argument. So let's get rid of this horrible code that I just introduced you to, and then make something new using arguments. We're going to make a function called greeter, and we're going to put it inside of an environment variable. The function is using these curly braces, and we need to add an argument to it. So an argument is a way for us to put something into a function and then use that inside of a function and then spit the result of it out. So the way you write an argument is almost the same as writing a local variable. You just write arg instead, and then let's name this argument name, because we want to make a function that can greet someone, and we don't want to define the name from the beginning. We want to be able to greet Giuseppe, we want to greet Mako and Mike, and we want this to be very flexible. So as I showed you before, we can write a string, let's say howdy, and then concatenate it with these pluses as I showed you before, and then the name, and we get a function. Let's try it and see how we can put a name inside of this. Greeter, that value, like we did before, and then we add a parentheses, and then Mike, and then we get howdy Mike. That's pretty smart. Let's I'm going to greet myself. Let's write mess. All right, this cowboy is out and about. There's a few ways that you can add an argument to it. What we did here was we just wrote a string, and then that's automatically put inside of this. This is the first argument. But let's say that we wanted to add a surname. So we add another argument called surname by writing comma and then surname. And we're going to use that as well. Comma. Surname. Let's say my surname is Vava. So then we add another argument like this. Howdy, Mads Vava. It's actually done. Remove this comma. Okay. Howdy, Mads Vava. And so the order of the things we put in here correspond to the order of the arguments up here. We can get them directly by writing name, colon, and then the argument, surname, and then argument. And this is the same. Now there's some tricky stuff here when you use this way of accessing the arguments. So sometimes, let's say I want only the surname here. How can I only write the surname? Then actually I just delete this part with the name and then only the surname. And then my name is Howdy Nil Vava because there's nothing in name. But then if I remove this again, then it becomes Howdy Vava Nil because now the surname doesn't have any value but the name does have a value. And we can mix this way of using arguments actually, so I can write Vava, surname, colon, Johnson. So now it gets Vava Johnson. But here's the trick, and this is one of those weird things in SuperCollider that would have frustrated you endlessly if I didn't just show you like I'm going to now. So I'm going to save you countless hours of frustration, because if you do mix these kinds of ways of using arguments, you will very quickly get into trouble. So let's say surname is the first thing I want, and then I add this afterwards. We get problems. So if you want to mix these two ways of writing arguments, then you have to write the arguments without a particular name at the beginning, and then at the end the ones with a specific name. So this is the wrong way. Let's document this. The wrong way, man. The good way. The good way. This is the good way. The good way. So let's just see once again what happens if I do this. Oh man. Then I do this. Oh yeah. Vava Johnson is back in town. Yep.
Now we're playing just with two variables, and we have like we are defining the second variable, putting surname, but we're defining both of them, but we are like specifying that the second one it's surname. We are like, I don't know how to say that, but we're just saying this.
Yeah.
So it kind of gives for granted that the first variable it's name, which is not specified. But if I have three variables, can I have like one non-specified one, a specified one, and again a non-specified one? Just because I still follow the rules.
Yeah. Yeah. That's a good question. So what happens if you take a non-specified argument and then a specified argument and then a non-specified argument? The short answer is you're going to get in trouble, but let's try it. Let's add a middle name here. Oh no, I messed up. Let's see. Like this. So I'm just adding empty strings here to add a space between the names, if you're wondering. Yeah, and I messed up. Name plus plus.
I missed one plus plus.
I missed the plus plus. Oh yeah, here it is. Yeah, you passed, Giuseppe. So let's see what happens here. Wow, I get a problem. But what if I do what you just said, Giuseppe. You said.
Yeah, I write like Varvar.
Let's just write Giuseppe because you asked the question. Giuseppe Johnson, and then let's say the middle name is Larsen. It's very probable. See, we get a problem again. But if we change things around
Yeah.
and put Larsen down here, then it works. But now your name is Giuseppe Larsen Johnson.
Alright.
So the unspecified ones are just going to start from the left in the argument list.
But now there is like sort of an identity because the first and the second and the third one correspond to name, middle name, and surname.
Yeah.
But
Oh yeah. Let's try.
my question was about the correspondence.
So like this,
Yeah, let's say.
middle name. So now you get nothing.
Okay, that it just doesn't. It just keeps large.
Yeah.
All right.
Because they're both passed into this thing. So this is put into Larsen, and then surname is still nothing.
So basically, Larsen is the middle name. Then it tells again, and middle name is Johnson.
Yeah.
And you have nothing afterwards.
Yeah.
All right.
And the reason I'm showing you, not only doing this to confuse you, it's also part of it, but I'm not only doing this to confuse you, it's just to show you this because you'll see this very often. Sometimes in SuperCollider you want to use something that makes sound, and it takes 20 arguments, but you only need to specify what kind of note you want, what is the pitch of it. And then instead of like remembering, okay, what was the number in the list of arguments, you can just write note, colon, this is what I want. But it's a bit tricky. I just wanted to make sure that you know that this is the business here.
But once you identify the arguments, even if the order is not the right one, they will work.
Yeah.
Like if you write surname and then name,
Yeah,
it would just
yeah.
like
Yeah, we can completely mess this up and saying middle name, colon, surname, name. Yo.
Yeah, right.
So that's also flexible because sometimes maybe it makes sense for you to write it like this, then you have the flexibility because you say specifically this is the middle name, specifically this is the surname, and specifically this is the name.
Especially if you don't know the order of the argument.
Exactly.
Yeah.
So if there is 10 arguments and you don't remember the order of it or the number of them, then this is the easy way to do it. Syntactic sugar, there's another way of writing this using these pipes. Just so you know. This is probably, using arg is probably better, but if you see those pipes, don't fear, it's just an argument. Yeah, and you can actually add default values as well. So if I want the name to be Mads by default, and then when we don't add any arguments here, we just write the middle name, for example, then it's going to use the default value, which is Mads. So you just say equals and then the default value. And you don't have to be 100% scientific about this. You can just remember, just use the ones that you actually need a default value for. You don't always need it, but it's possible. Yeah.
You have to rerun the function before you use it again.
Yeah. So if I change it.
Yeah, if you change it, yeah.
Yeah. Then I have to run it again, and then.
Okay.
Yeah. And this is one of the cool things with SuperCollider, because with some other languages like C-based things, then you have to like write the code and then press a button and then wait, and then it's running. But you can actually this way you can code something that's going on here and something down here and then blah blah blah. You can jump around because you just code bits of it at a time, and then maybe at the end you have this really nice piece of code, but that's rarely the case. So you can be very chaotic. I think that's why it works so well with art, and for artists as well, is that you can just, I have this idea now, I'm just going to put it in here. It doesn't matter where it is. It's just, I just want this grid written right now. It doesn't matter where it is. So that's a good point. Yeah, different ways of writing the same thing. Arguments. Yeah, and functions work like code blocks as well. So whatever's at the end is being returned. So you can see this is the return value of this function. But if I put the number 10 at the end here and then return it again, we don't see anything printed. We just see the number 10 being returned. So the last thing in the function is returned. And the same thing goes for any code block in SuperCollider. That's it. Now you can breathe a bit and kind of think about this whole nightmare we've been through together. Because that was the code that we had to look at today. And I'm going to end on this note, which is how do I continue from here? Well, download these slides that I just gave you a link for on my website, and kind of look back at them at some point once you feel like you've regained some energy, which may be a while after this horrible talk. But once you've done that, I would encourage you to continue learning SuperCollider, and there's a lot of ways you could learn it, and a lot of really good resources. They can be really hard to find, but I've made it easy for you. If video tutorials are your thing, then there's really good ones on YouTube by Eli Feldstiel. He has this quite thorough and nicely paced introductory video series that's he's been working on for years, and it's still being developed. So that's super nice. If you're more into reading, then I have a few recommendations there as well. There's a couple of ebooks here, and in the slides these are links, so you can just press them and you get the books. The first one is what inspired me to call this a gentle introduction to SuperCollider, even though it's the exact opposite, horrible introduction to SuperCollider. But this book is super nice. It's free. It's a free ebook made by Stanford, and it's pretty thorough, and it is actually gentle. It's not like me saying things are gentle when they're not. It is actually a gentle introduction. So I would recommend very thoroughly this book, also because it's free. Thor Magnusson has this book called Scoring Sound, and that's another free ebook. You can choose to donate some money to him if you want, but it's free. And this is kind of different to the first one, because this is more like a cookbook containing specific recipes for making this kind of sound, or if you want to make a delay sound that sounds like this, and blah blah blah. So he has done a lot of the hard work, so it contains a lot of really nice kind of recipes for doing specific things. And there's a couple of paper books as well. Introduction to SuperCollider by Andrea Valle is by far my favorite. It's fantastic. Right now Harald has the one that Notam owns, but we have a copy here that you can borrow and use. But it's a super nice book, and I can't recommend it enough actually.
I think you also find the free PDF online.
Yeah, there's a free PDF in Italian. So I think it was originally written in Italian. But if you know Italian, which I guess you do, Giuseppe, then that's a good thing. If you want to
in English as well, but
yeah, I mean, and how hard is it to learn Italian? You just learn Italian and then you read the book. If you want to save 30 euros, you can do that. And then the SuperCollider book, which is this one right here. It was released a few years ago. This is a very good book. It's not very pedagogical, so please don't start your career with SuperCollider with this book, because it's kind of a compilation of different texts covering different subjects. But it has some really amazing stuff in here actually. But please don't start learning SuperCollider with this book, because it will break your neck. And there's a lot of places where you can get help. As I as I said before, there's a big community around the world. Here are some links to some of the places. I think this is the best actually at the moment, scsynth.org. It's an online forum that works really well. And then there's a bunch of other places you can get help. There's a Facebook group that's really good. The mailing list is kind of the classic. It's if you haven't dealt with this kind of stuff before, then you probably, maybe you don't even know what a mailing list is, but it's a very old school way of making a forum on a mailing list. And this one has been running forever, and it just contains so much information. But it is, it's harder to use than a normal website, I would say. So I recommend this scsynth.org if you want help. It's rather new, scsynth.org, so it's not, doesn't contain as much information as some of the other ones do. There's a Slack if you want to chat with people, and there's a Lurk channel, which is kind of the same as Slack, but this is focused on live coding. And then there's this amazing link to something called Awesome SuperCollider, which is a list that I've compiled, and which I've gotten some help from the community as well to make. It's a list of things that are really cool and SuperCollider related. Because sometimes people make something and it just disappears in the depths of the internet. And I've tried to gather the things and curate the things that I think are cool and I think people should know about on this list. And so it's actually pretty nicely organized, if I say so myself. So it's got different chapters here, so whatever piques your interest. So learning resources, there's a bigger list of resources here. The ones I just gave you are a bit more curated to your needs probably, but there's tons of resources here if you want to make 3D and SuperCollider, for example, or work with motion tracker for dancers, then there's tutorials for that. So this is, I'm not only saying this because I made it myself, this list, but it's a good list. And then the last slide, learning to code. Just practice a bit. It's a bit of advice. Just practice 5 minutes every day. You don't even have to use the computer. You can just be in the shower and you can think, okay, var equals string var equals var. You can, just think about it a bit every day, and then very quickly you will gain a lot of practical knowledge with SuperCollider, and it will be easier to use. If you use it a bit and then you leave it for a month or two and then you get back to it for a bit and then leave it a bit again, then it kind of becomes a bit heavy. But this isn't only for SuperCollider, it's for any technology that you want to learn. And then use the community. Either come to our meetups every month and ask questions and be like, oh my god, I need help for this thing that makes noise. It makes too much noise. And we can probably help you, or you can ask the people on the internet. So really, really use this. I can't stress it enough. You're not alone. Use the community.